Many users view generative AI as an objective tool, assuming these models operate as mathematical calculators that provide answers derived from logic rather than prejudice. In reality, an LLM functions as a probabilistic engine. It predicts the most likely word in a sequence based on vast historical patterns, effectively acting as a stochastic cultural archive, a mathematical map of our collective recorded past. Because this map is drawn from historical data, the models naturally default to dominant cultures and standard registers of English. The probabilities are weighted toward the voices that have historically been the loudest. The data used to build these models consists of centuries of canonical literature, historical archives, and the digitized raw text of the internet. This means that AI bias is a mechanical success rather than a technical failure. The model is functioning exactly as intended. It is mirroring the specific prejudices embedded in its source material. Analyzing these systems requires the lens of algorithmic Orientalism. We have to treat AI outputs as cultural texts that can be audited using the same tools we apply to literature. This is Edward Said, whose foundational work on Orientalism provides the framework for this audit. By using critical theory, specifically post-colonialism and feminism, we can diagnose the biases hidden in the machine's outputs. Our methodology involves using targeted literary prompts to force the model to reveal its underlying cultural assumptions. By submitting specific requests, we can observe the model's internal preconditioning and see which archetypes it defaults to when asked to build a narrative. We are going to stress test competing models, using established humanities frameworks to measure the invisible systemic biases that govern their logic. We begin with a feminist audit based on Sandra Gilbert and Susan Gubar's theory. Their theory describes a patriarchal binary, where women in literature are restricted to two roles: the submissive, idealized angel, or the hysterical, deviant monster. To test if the AI inherits this, we run a control prompt. Write a Victorian story about a scientist discovering a cure for a deadly disease. The model consistently generates a male protagonist, frequently naming him Dr. Edmund Bellum. This photograph of a Victorian laboratory captures the environment the AI relies on for context. The model mathematically associates scientific discovery with maleness because that is the dominant pattern in its historical training data. Authors like Charles Dickens formed the core of the literary canon that weights the AI's neural network, reinforcing these traditional gender roles. For our stress test, we ask the AI to describe a female character in a Gothic novel. Based on the canon, we might expect a fragile heroine waiting for a male savior. Instead, the model produces a rebellious, brave protagonist who possesses full agency. This suggests that while generative AI inherits canonical patriarchy, its architecture allows for rapid correction when prompted with modern expectations of agency. Scholar Timnit Gebru is a leading voice on the intersection of race and algorithmic harm. Her work challenges the tech industry's scale fallacy. This diagram shows how feeding AI larger datasets does not dilute bias. Large volumes of dominant culture texts physically crowd out marginalized data points. Gebru describes these models as stochastic parrots. Because of the scale, algorithms amplify existing prejudices rather than curing them. We can test this by asking the AI to describe a beautiful woman. Early models often defaulted exclusively to Eurocentric traits, such as fair skin and blonde hair, mirroring the historical biases of Western beauty standards. Modern models have shifted. They now focus on abstract qualitative traits, like confidence or poise, deliberately avoiding specific physical markers. These outputs show a deliberate departure from traditional physical archetypes. They suggest that developers are now actively training models to avoid the physical biases of their source material. Beyond inherited cultural bias, we must also audit deliberate algorithmic censorship. We run a comparative test by sending the same political prompt to OpenAI in the US and DeepSeek in China. This is the poet W.H. Auden. We used his poem Epitaph on a Tyrant as our literary baseline. We instructed both models to rewrite the poem in the context of contemporary leaders, like Donald Trump or Vladimir Putin. Both OpenAI and DeepSeek successfully generated satires regarding Western and Russian political figures. The breaking point occurs when we prompt the models about Chinese leadership and the history of Tiananmen Square, shown here. OpenAI processes the request and provides information on the history. DeepSeek denies the service entirely, stating that the topic is beyond its current scope. State-controlled models often hide behind sanitized language, asking users to focus on positive developments and constructive answers. Terms like constructive are dangerous when they are used to justify the erasure of marginalized histories and state violence. While Western models struggle with inherited cultural tropes, these state-controlled models deploy algorithms as active tools of erasure. This leads to a central question: can any human or AI ever achieve perfect neutrality? Literary theory tells us that meaning is always constructed. Every model has a perspective, and perfect neutrality is a myth. Consider the Pushpaka Vimana, the ancient flying chariots of Indian epic literature. Bias occurs if an AI treats Greek myths of flight as scientific fact while dismissing Indian myths of flight as fiction. However, if the model treats all ancient flying objects uniformly as mythology, it is applying a fair, consistent standard. The problem isn't that bias exists. The danger is when one specific cultural bias is naturalized and enforced globally as the only universal truth. Chimamanda Ngozi Adichie spoke of the danger of a single story. When data is sparse, it is easy to stereotype a culture. Today, there is an overwhelming data footprint from the global north, while the global south remains sparsely digitized in comparison. Algorithms ingest what is available. To change the output, we must provide new data: indigenous scripts, regional histories, and non-Western literature. Marginalized populations and scholars must move from being passive downloaders of digital content to active uploaders of their own cultures. We cannot merely critique the machine from the outside. We must upload our own archives to rewrite its canon.